Section 15B.2, question number 4, page 367. The question tells us that the gradient function of this original function is given by 24x squared minus 24x plus 6. We need to find constants a and b. So, because we're given what the gradient function is, we can take this function and find the gradient function of that by differentiating. So we can go ahead and do that. So f prime of x. Again, we'll just follow the chain rule, so bring the a down in front, leave 2x minus b as it is, and then we'll subtract 1 from the exponent, which is a minus 1. And then we go on the inside and take the derivative of that, which gives me 2. And I'll simplify a bit by bringing that to the front, so I have 2a times 2x minus b, all to the a minus 1. Now this is a different form than this, so right now things aren't really looking that sweet at the moment. So what I'll do is I'll see if I can factor this into a similar form as this. So I can factor out a 6 here to start to give me 4x squared minus 4x plus 1. And then if I take a good hard look at this, I'll see that that is a perfect square trinomial. So that can be factored down to 2x minus 1 all squared. Now that we have this gradient function in this form, we can now compare it to the same parts of this function to see what we get. Okay, so I see that the coefficient here is a 6, the coefficient here is 2a, so I can say that 2a equals 6, and I just solve for a equals 3 by dividing both sides by 2. I could have, as another way, I could have also taken the exponent, a minus 1, and set it equal to 2, and this will just kind of verify this part. So if I said a minus 1 equals 2, I solve for a, or isolate a, which gives me, by adding 1 to both sides, I get a equals 3. So either way, a equals 3. Now I'll take inside the bracket, we've got 2x minus b, and that has to be equal to 2x minus 1, and everything is the same, so therefore I can just eliminate things and realize that b equals 1. So therefore a equals 3 and b equals 1.